Welcome everyone. We are going to present today a project in natural language processing. The team was Sahil, Soumya, Navdeep, Alex, and Prama. The topics of the day are objective and scope, overview of NLP, cloud technologies, results and analysis, and a live demo. And of course, the key takeaways from the project. Soumya is going to introduce you to objective and scope.
Hello everyone, this is Soumya. I will walk you through the objective and scope of this project. Our objective is to extract expressions of opinion by describing a target feature and classify them into multiple categories. The learning algorithm used will learn various emotions from the text and determines the mood of the user. The scope of this project would be implementing sentiment analysis on all the three cloud platforms, namely Microsoft Azure, Amazon Web Services, and Google Cloud Platform. Now let's look at the dataset. The dataset we have used contains two columns. The first column describes the text in a comment, and the second column gives the sentiment of the text. The various categories in the sentiment column are achievement, affection, bonding, leisure, nature, exercise, and enjoy the moment. We would be classifying the comment based on the model and derive the emotion of the text. In this dataset, comment is considered to be the feature column and sentiment is considered to be the label column. Now, Sahil is going to talk about the overview of NLP.
Hello everyone. So I'm going to walk you through the branch of an artificial intelligence that's natural language processing, which is fashionably known as NLP. It is concerned with interactions between computer and human languages. It is basically a bridge between human communication and computer understanding, that is semantics identification, language detection, etc. NLP reads the text, listen, indent, and analyze it as a result and measures the sentiments, whether it is positive, negative, or mixed. NLP has various branches which I'm going to explain you. The first is content categorization, which is categorizing the content. The second is sentimental analysis, which is identifying the mood or opinion. The third is text to speech, which is converting text to speech and vice versa. Then the fourth is document summarization, which is creating a synopsis of a long text. Then the fifth is machine translation, which is automatic translation of text or speech from one language to another. We are majorly focused on semantic analysis, which is called opinion mining, which concerns with identifying and extracting moods, reviews, and opinions within the text, and even extract the attributes of expression like polarity, which is positive or negative, subject, and the opinion holder. It transforms the unstructured information into structured data of opinions about products or services. This is useful in customer service, market analysis, and public relations. So for this, we have used three cloud platforms, that is Google Cloud Platform, Microsoft Azure, and Amazon Web Service. With that being said, I would like to pass the control to Navdeep, who will be explaining the services of all the cloud platforms.
Thank you, Sahil. Now I'm going to talk about the machine learning services available in each cloud platform and also what services did we select for running NLP algorithms on the dataset selected. Let's start with Google Cloud Platform. As we can see from the presentation, there are 14 services in Google Cloud. There are various services for machine learning, computer vision, big data, and text-to-speech conversion. For our part, we use the Google Cloud Platform AutoML, which is a suite of machine learning products that enable developers with limited machine learning expertise to train high-quality models specific to their business needs. It relies on Google's state-of-the-art transfer learning and neural architecture. We used AutoML natural language pre-designed model to classify, extract, upload the training dataset, and then test the custom model and detect the sentiment. Let's move on to AWS. For AWS, we have 12 services for running various machine learning algorithms. The services are mainly focused on computer vision, deep learning, and artificial intelligence for forecasting and prediction. For our project, we used Amazon Comprehend. Amazon Comprehend is a natural language processing service that uses machine learning to find insights and relationships in the text. Comprehend uses machine learning to help uncover the insights and relationships in structured as well as unstructured data. The service identifies the language of the text, extract key phrases, places, people, brands, or events, understands how positive or negative the text is, analyzes text using tokenization and paths and parts of the speech and automatically organizes a collection of text file by topic. AutoML capabilities and comprehends are used to build a custom set of entities or text classification models that are tailored uniquely to the needs of the client. Lastly, let's move to Azure services, which are 36 in number, the highest by far. These services range from computer vision to text processing and also include genomics data analysis, which is one of its kind in any cloud platform. We used Machine Learning Studio, a graphical user interface-based integrated development environment for constructing and operationalizing machine learning workflow on Azure. ML Studio has pre-built text analytic package which can identify many different languages. We can specify the string column to analyze and the total number of languages to detect, and the algorithm will analyze each row of text and the results are displayed for the data. Now I will pass on to Alex for analysis and results, which are done using Google Cloud Platform, as it shows the best result with its out-of-box algorithms.
Thank you, Navdeep. So we analyzed 12,663 text items, which all had a positive emotion related to them. So we analyzed this using the service AutoML natural language, which proved to be the most practical one and who had the best results. Multi-level classification, as we had many different possibilities of labeling for each text. Look at the precision of the model. We can see that we got great results. The precision means that the amount of the false positive, it was very low. In recall, we also have a great outcome. So with this level of recall, we know that the amount of false negative is below what would be considered too large of an amount. Go to a live demo. We're going to use a phrase that was given to us by our instructor in last class. Thank you, Professor Habibi, for this phrase. It's up to you guys. Let's see which emotion is related to this sentence. So our algorithm says that affection is the strongest positive emotion related to it, as well as enjoy the moment. So I guess we have to thank you, Professor Habibi. Let's try another one. Loved working on this project. So clearly this is an achievement emotion as well as an affection. So I guess we feel like we did a great job. So now I'm going to show you the Python code at the end. So if you want to modify the out-of-the-box solution, you can add some code in this section. However, we were pleased with the results, so we only use what we felt was the best option. Okay. Now, Soumya is going to explain you the key takeaways from this project. Pramod, sorry.
Thank you, Alex. Hello, everyone. This is Pramod, and I'll be talking about the key takeaways from this project of running the sentiment analysis on 3 cloud platforms. We will talk about this setting up the storage, how to process, and the algorithms used. Firstly, in Azure, we have uploaded our data into datasets using Azure ML Studio. Then we created the experiments to pre-process the data, such as stop post removal, extracting n-grams, and then we have used multi-class logistic regression to analyze the sentiment of the text. Secondly, on AWS, we've used S3 buckets for our data storage. Lambda function is used to read the data from the S3 bucket. Amazon Comprehend is used for performing sentiment analysis on the data by using Boto 3 in Python. Finally, we have loaded the data to the buckets in Google Cloud Platform. We've used Google AutoML to fetch the data from the bucket, and multi-class classification algorithms is used for the analysis. With this, I will hand over to Alex for the conclusion.
Thank you. So as you can see, the technologies available online in cloud technologies for machine learning are great, and we consider that in the future we'll first attempt to solve any problem with Google Platform, as it has the easiest solutions or the most straightforward, but Azure will have the most diversity. So yeah, it's been a great learning experience, and I hope you enjoyed it. Thank you.